So TxOne, excuse me, who is TxOne? First of all, you may have known the Trend Micro name. TxOne is actually a subsidiary. We were spun out to focus specifically on IoT and control systems, operational technology. So that's just kind of a brief introduction of who we are. A lot of you may have not heard of us before. Understandably, fairly new adventure for Trend Micro, but specifically focused on, like I said, operational technology and protection of operational technology. So I'm a principal.
Jim,
yeah.
Jim, just to clarify,
yeah,
TxOne used to be part of Trend Micro, then Trend Micro spun it out as a separate entity focusing just on IoT. Is that correct?
Generally, yes. We are still a subsidiary of Trend Micro currently, but moving that direction, definitely. Makes sense?
Okay, so it's a separate autonomous entity focused on this important issue, namely security in manufacturing, supply chain, industrial systems.
Exactly.
Okay.
Thanks. So why are we here? Zero trust. Zero trust is an interesting concept, and I know it's bantered about quite a bit. Zero trust really goes back to the 70s when you talk about the principle of least privilege. That was created, or the philosophy was created back in the 70s. We obviously didn't pay a whole lot of attention to it over the last 30 years or so. But it's come full circle, right? So there's a number of reasons for that. In IT, you have remote workers, cloud applications, you have a lot of IoT devices, meaning, refrigerators, stoves, iPhones, all the stuff that's going on inside your home environment, connecting to corporate networks, enterprise networks. Those are the biggest challenges. As a practice, you're managing the user. So you're managing the user and machine authentication, access control, using NAC, network access control types of capabilities. A little bit different though when you move into OT, because you're really moving from managing the user and their access to managing a device and its access and how it communicates within this very large flat network that's been created for manufacturing, for any number of critical infrastructure, oil, gas pipeline, electrical delivery, wastewater management, water delivery. All of those things are part of the challenge when it comes to enforcing security privilege on critical infrastructure. So there's a number of things we want to do there. We want to verify what we're bringing into the environment. We want to default deny applications, because if we don't know what an application is running in an operational technology environment, moving power around, moving water around, turning on and off gas pipelines, there's a real possibility of very serious complications. We saw that with a Colonial Pipeline, no loss of life, but that's a complete shutdown of the East Coast. So that's kind of one of the reasons, or one of the motivating factors, that we are focusing on this specifically, and specifically trying to protect critical infrastructure and any type of pipeline manufacturing type of infrastructure that can be impacted utilizing operational technology vulnerabilities, or just getting into the environment and doing detrimental activity in the environment. What's the reason? Why are we actually doing this? So in IT, like I said, we're protecting the user. Stolen credentials is a really good example of that. In OT, an asset can be, it says evil. I should have changed that. I don't like the evil, but it could be malicious, right? It could have something happening on that specific access, whether it's infected by a virus, whether there's some sort of vulnerability with a backdoor, whether critical processes have been compromised, whether someone has access to the HMI or SCADA and can actually now program or reprogram the PLC and make changes in the environment. The implications are very serious, especially when you get into OT environments, and that's what we're trying to stop. That's what we're trying to promote throughout operational technology, industrial control systems, is the ability to protect and the ability to stop this type of activity from happening. Let me just build this slide. So how did we get here? This is basically chain of events of what happened. But starting back in 2010, you guys may remember Stuxnet. I won't talk about it. Stuxnet was kind of the beginning of all this, right? Of all the nation state things, the attack on the environments. A lot's happened since 2010 for sure. The big critical change was late 2017 into 2018, moving into 2019. The attackers discovered that, hey, we don't need to have an ICS specialized attack. Active Directory is moving into IoT environments. NB is moving into industrial control systems. So why don't we just utilize this living off the land philosophy that we've been using in IT for so long? Let's use an OT. So the methodologies changed a little bit. They started using the attack vectors, if you will, that were common in IT and moving into the OT environment. So we see a lot of transition when you're talking about attacks on operational technology, a lot of transition from Active Directory environments utilizing the IT environment to actually propagate inside of the OT environment and move into that OT environment. So that's the critical juncture. The other complicating factor is COVID. Everybody's remote now. Nobody can go into the plants. You don't have remote access, or access is extremely limited. So there was a need for that external communication, and there was a need specifically for access into those plants. But you're moving into production environments that have unsecured protocols, really weren't built for remote access or to protect against remote access types of vulnerabilities or capabilities. So there's some huge challenges there when you talk about trying to bring an operational line, some sort of manufacturing or some sort of critical infrastructure, bring it into a modern type of technology connection through VPN, whatever. You're introducing a lot of risk. That's the reason we have company is focused on this specifically, is really to dig deep into this and bring protection, but also bring some visibility. So deployment obstacles, there we go. Deployment obstacles, if you're working in manufacturing, if you're working in critical infrastructure, there's a lot of obstacles. So installation complexity. So you're dealing with large, complex procedures, space, power, cabling. There's a lot of moving parts. So it can get very complex, especially in large organizations. And we work with some global organizations that the complexity is just, it's kind of mind-boggling, especially for enterprise security, because they're having to tackle this problem. And they look at the problem as a whole, and it's extremely large, extremely complex. It's like, where do you start? That's one of the biggest challenges we find is that starting place and where we actually start digging into protection strategy. Legacy assets, XP is rampant. I actually ran across an NT server a couple of weeks ago, which was kind of scary. But really old stuff out there. Predominantly it's 7 and 10, Windows 7 and 10 right now, but there's a lot of legacy stuff out there that they can't change. Either it requires the purchase of new equipment, which is a huge investment possibly, or it requires rebooting a system that you just can't reboot for a number of reasons. And that goes to my next step, which is availability. I'm extremely sensitive to availability in the environments. You can't keep rebooting systems and installing applications, or you can't keep stopping applications from running if they are controlling motion on a line, if they're controlling, again, utilities. You just can't stop them, and availability is the king there. If you stop availability, you stop the progress, and it can either mean money or it can mean impact further down the line to the system.
Hey, Jim.
Yeah.
Ian asked a question just to clarify what exactly is the paradigm shift. As I understand that, you can clarify this, the big shift is having industrial manufacturing supply chain systems that were previously a closed loop, standalone secure system with not so much PLCs, but also ASICs, meaning application-specific integrated circuits that you never really changed, sure, that were not really part of the IP network, weren't really part of your normal firewall. and the big paradigm shift is that as people want to use their smartphone to monitor industrial systems, want to track things, that's the big paradigm shift that placed the risk of cyber attacks affecting industrial systems much more prevalent. Is that a reasonable summary?
It is, but I would add, or I'd actually move back a little bit further into that, to the shift when we started looking for logging, when we started looking for telemetry out of the IoT or ICS environments. And that's kind of when it started. So when we decided that we wanted to no longer have air gap and start either having access via some of the tools and methodologies that you mentioned, or that we wanted to start gathering, collecting telemetry out of the environment, you're opening it up. So that honestly, there are, I want to say no, I'm not going to say no, but there are very few environments that are truly air gapped anymore. You just don't see, there are some very secure environments that people have done that with, but it's exception, it's not the rule. So when we started asking for telemetry, when we started asking for logging, when we started asking for access to manage or monitor within the environments, that's really when the shift happened. COVID accelerated it enormously. And that's when you start limiting physical access. Now you have to have some sort of availability to access and get in and do things. But that's, hopefully that answered your question. But I think that shift really happened a little bit earlier than the access point.
Okay, thanks, Jim.
Sure.
Always want to make sure we get interaction and get questions answered as much as we can. Anything we don't have a chance to answer, I'll send follow-up emails. And again, all the content's going to be available for downloading.
Yep, absolutely. So vulnerability, we all know what the vulnerabilities are. Insider threats, so someone going into the environment, and this can be intentional or unintentional, right? So this can be someone physically carrying a USB device in, going to and do something malicious in the environment, or this could be a contractor coming into the environment, unknowing, bringing a malware in with their laptop or what they're connecting to your network with. So there's a couple of challenges there. Rogue devices, unmanaged devices for visitors, talked about that. Flat network, non-existent network segmentation. I mean, I go into these huge, complex manufacturing environments, just a wide, flat network that everything's connected to. So, as you can imagine, if something gets in, and if it can propagate, it will. Patching, again, availability is everything, and patching is kind of a no-no in the environment for a number of reasons. Number one, they don't want to have to do reboots, but number two, you may not be able to change the operating system or modify it in any way or install an agent based upon the vendor's requirements. So there's a lot of that. There's a lot of control in the environment, specifically when you're talking about life sustaining devices in medical. You can imagine they're a little sensitive to changing things. So those are some of the variables and obstacles, but it is possible. So I want to build this slide a little bit. When you look at this slide, one of the keys is to determine and to basically sketch out or map out your environment, what you can protect and what you can't protect. And there's a few different layers or levels of protection. The first is you want to maintain a trusted operation. So if you can install an agent that can either do application control or can do real-time scanning on a operational technology type of device that's built for this environment, extremely low latency, extremely low impact to the operating system, you absolutely want to do that because you want to stop the propagation, but you also want to stop the actual infiltration or downloading of malware or the installation of malware. Typically secondary attack vector is download or installation of malware. The primary attack vector is creating a backdoor or creating a mechanism for that download, whether it's SMB, whether it's a backdoor, whether it's Active Directory. In a lot of cases, is the file is assigned via Active Directory. So when these guys go out and log on, they're actually pulling the malware and it's propagating via Active Directory, very common attack. But you want to protect what you can, right? So these are typically Windows, Linux operating systems, and giving you the ability to stop either real time or from an application control. New assets, into the environment, absolutely want to scan them, you want to validate them. But more importantly, you want to understand what they're doing in the environment. You want to understand the configuration, the communication, who is talking, why it's talking, what the implications are. So baselining that new device as it comes into the environment, and then understanding basically the current environment and what's happening in the environment, and then using your protection strategy on that. So this is your basis for, how much time do I have left? 5 minutes?
Yeah, we've got 5 minutes.
Okay, pretty good with time then. So this is really the baseline for forging zero trust approach, because once you understand the environment and you've started to form some protection strategies on devices that you can protect, now you start looking at a model for segregation. So taking each station and isolating it via network division, whether that's either physical networking and virtual networking, but just making sure that can't propagate within the environment. So this is global, kind of a general approach to, or how we approach zero trust in the environment, and then fortifying the operation and continuing to monitor with your current controls. We talk about installing agents, understanding that it is a sensitive issue, but going back to the ability to protect what we can protect with an agent-based either real-time scanning or application control, and then moving to the network layer for the additional controls. So doing intrusion prevention of the network layer, doing application and protocol control. So who can talk to who, and even down to the protocol level, what can this protocol pass to the PLC? Can it read only? Can it write? Can it modify? So we can actually get down to that level. And if we can get down to that level, we can then create that network segmentation between either the station, the zones, or even for the entire shop floor, getting down to each individual station within the shop floor. So a little bit more about the process, device onboarding. So when you're bringing the device in, doing the integrity checking, making sure the configuration is what you desire it to be, and then learning about the asset information. So that's the critical onboarding capability. The application activation. So what does it do? When is it doing it? What should it be communicating to? And is this the right thing for it to be doing? Anomalous communication, it's a critical function of what we try and do also in the environment. So once we understand what it should be doing, then we move to, okay, well, if we know what it should be doing, what's the good behavior? What's the good traffic versus, okay, I've never seen this before, or hey, you just opened this valve to 100%. That's never happened before. This is not right. So those types of anomalies, while they may not be out of scope for the protocol, or out of scope for the environment, and out of scope for normal in the environment is. So that's part of our approach in looking at internally looking at the environments. Talked about network communication a little bit. This is really where we do the microsegmentation, where we shield the assets from vulnerabilities. We use a number of tools to develop shields for vulnerabilities specific to operational technology. So, we're not trying to protect against Adobe vulnerabilities inside an OT environment. We're trying to protect against, Windows specific or application specific Siemens or protocol specific Modbus from changing or modifying your environment. So that's the nexus or the crux of what we're trying to accomplish. But again, going back to a multi-layer, going back to, hey, this device, we understand what it should be doing. We want to limit it to capabilities that it should have, and not allow it to either propagate to outside of its own workstation or outside of its own station on the line in the environment. And we also want to protect the rest of the line via microsegmentation, so that cannot communicate to any other station or substation within the environment, and either propagate or even communicate if we want to lock it down that far.